Hello all, greetings of the day. I am Aniruddha from Maharaja Institute of Technology, Mysore from Department of Civil Engineering. I am here to share with you my learnings that may help you learn the subject called fluid mechanics. Now, why are we here today? It is because the pandemic has pushed us to be here. That means in the conventional classrooms, I would be watching what you will be doing, and you will be watching how I would be teaching. But this pandemic has pushed us for online classes or recorded classes, which are the new normals. So we will have to adjust to this. I wish I could be of some help to you during this transition. Now, since 8 years, it has been my practice to start the classes with one thought per day. I will do the same here also. Education is what survives when what has been learned has been forgotten. I hope all of you become educated, not just the banks of knowledge, but you also have to be educated. Now, what is this subject all about? As I have told you, the name is fluid mechanics. It has two parts visibly. One is fluid and the other one is mechanics. I will start with the later part of it. That means mechanics. Now, in the third semester class that you are listening to, you will have two types of students. One is from the PUC background, the other one is from the diploma background. Those who are from the PUC background would have studied mechanics as engineering mechanics in the second semester of BE, whereas the diploma students would have learnt it during their diploma course. Now, to begin with the mechanics, I will have to go little further into the study of basics, that is mechanics. Before I forget, I should bring it to your notice that this is not the actual class that is dealing with the first module or the types of modules that we have in the subject. This is a sort of bridge course between what you have already learned and what you are supposed to learn in future. It may not appear in your examination, but this is the foundation on which you can build the structure. So, we will begin with mechanics. What is mechanics? Probably most of you would be aware of what is the meaning of mechanics. In a regular class, I would have posed this question to you and you would have answered with your known past history. But today, I will have to ask the question myself and I will have to answer it myself. Mechanics is that branch of science which deals with the study of forces on the bodies at rest or in motion. I repeat it because I will have to take two things out of this definition. Mechanics is that branch of science which deals with the study of action of forces on the bodies at rest or in motion. There are a few takeaways from this definition for me, because that is where the basics are now hidden. Now, a few things that came into picture. Starting from the definition of the mechanics, you have study of action of forces. So, that means you will have to know something about forces, study of action of forces on bodies. You need this, bodies. Let us see what is that. Bodies at rest or in motion. Rest and motion. These are the few things that I will take out from the definition. Now, I will reformulate the definition, or at least I will repeat the definition so that I can pick one by one. Mechanics is that branch of science which deals with the action of forces on the bodies at rest or in motion. I have taken out forces, bodies, rest and motion. I will start with rest and motion and I will then go to bodies and forces. Now, what is rest and motion? Have you ever heard about it? Rest and motion are said to be relative. That means if a body is at rest, it cannot be in motion. If a body is in motion, then that cannot be at rest. That means what is rest and motion? To study what is rest and motion, you will have to know by what method we learn science. We will always learn it through two frames. One is time, the other one is frame of reference or space, that is called space. Basically, it is time and space. So, if a body is said to be at rest, if a body is to be said to be at rest, it should not be in motion with respect to the frame of reference and given time. Now if you observe, I am walking in the class. Now when I walk, what do you say? You must say that this body is in motion. Why? Because this body is not at rest. From the point where you are seeing, I am moving, but I am situated in a classroom. The classroom is not moving. For a person who is outside this building, this entire classroom is at rest. The body that is moving inside is not visible to him, so this entire room will be at rest for him. So frame of reference or space is very, very important. And now the same body which is in motion is seen as the body at rest from the other reference. And now after a few seconds I have stopped from moving. That means with respect to time, the body that was earlier moving has come to rest. So the rest and motion are, that is why said to be relative. A body that is moving cannot be at rest. A body that is moving, a body that is at rest cannot be moving, but that has to go with the time and space. So how do we define rest? A body is said to be at rest if it is not moving with respect to a particular given time and frame of reference. Similarly, what is motion? Motion is the state of body which is not at rest with respect to given time and frame of reference. So now I have told you that after studying rest and motion, I will go to bodies and forces. Even now when I define rest and motion, the body was there. What is the meaning of that body? Anything on this earth which is now considered for the study is supposed to be termed as a body. A body can be of three types. You know it: solid, liquid or gas. I will come to it little later because I am still to deal with mechanics. Now the other part here is forces. What do you mean by force? To know what do we mean by force, we will have to dig little more deeper so that we will know the basics of forces. This is now given by whom? Any action, any external agency that tries to do something can be termed as force. Now what do you mean by force is a point of reference for studying inertia also. What do you mean by inertia? Who has given us the content about inertia and force? That is given in Newton's first law. You must have studied this, Newton's first law. What is this law all about? Can anybody remember this? You tell it to yourself because you cannot definitely tell me now. So you can tell it to yourself. What is Newton's first law? Newton's first law states that every body continues to be in the state of rest or in motion unless compelled by an external agency. That external agency is what I am terming as force. So every body continues to be in the state of rest or inertia or in motion unless compelled by an external agency. Say for example, I keep playing in the road. So that's an action. Unless I am called by my parents to get in, I will not get in. So that is an external agency. That external agency can be termed as force. So if you apply some force, it can, see, first time when my parents call, I may not get in. Second time when they call me, then also I may not get in. But the third time when they definitely scold me and call, I will get in. What has changed is the application of force has been changed. The external agency has changed. So with that I can understand how anything that is applied is a force, but that force can alter the body's nature or it may try to alter the nature of the body. That means if you are running towards me and if I try to stop you like this, if the force that you are running with is too high, the hand that I am trying to stop you may not be sufficient to stop your run. So that is only trying to alter your the body's motion. And also I may be now asked to lift a big rock. I will try to lift it, but I will not be able to lift the rock. So that is why I am telling that external agency which is applied on a body may alter its state of rest or motion. If it changes also, it is a force. If it doesn't change, then also it is said to be force. So now, with the Newton's first law, we can now understand the magnitude of force is also very, very important, and the direction of force is also very, very important. I have told you that I will have to lift a rock. To lift a rock, what will anybody do? Even for lifting a paper, say like this, I have a paper in my hand. To lift this paper, what should be done? I will have to give the force from the bottom of the paper. Then only it can be lifted. So this is the direction of application of force. Instead of this sheet, if I have a 100 kg book or 100 kg block, can I lift it like this? I can definitely try to lift it, but I will definitely not be able to lift it. So what I mean to say here is the force that external agency can try to alter or it can alter. In this case of paper, this has tried and it has successfully altered the position of the body. Now what my point here is, I will have to take out two things from here. One is about the quantity. To quantify anything, you need two things. One is magnitude and direction. So before which I will have to go to the part quantity. What is a quantity? Anything that can be measured is a quantity. To how do we quantify? So you have two classifications, scalars and vectors. What is a scalar quantity? Any quantity that requires only magnitude to represent them are called scalars. Then what are vectors? A quantity which requires both magnitude and direction to represent them are called vectors. So how do we, can you give an example for a scalar quantity as well as vector quantity? Now I have told you that scalars will have only magnitude and vectors will only will have both magnitude as well as direction. That is the reason why vectors are also called scalars with a direction. Now when I say you have magnitude only to represent them, what does that mean? I weigh 100 kilograms. Let me say that I weigh 100 kilograms and my friend weighs 50 kilograms and I am running at 10 kilometer per hour. My friend is running at 10 kilometer per hour also. Now what I have mentioned here is, I will note it down for you, 100 kilogram and 10 kilometer per hour. These are the two things I have given. 10 kilometer per hour, in which direction I have not told. That means it is only a scalar. So this will become an example for scalar. Now when I say I run 10 kilometers per hour towards Srirangpatna starting from Mysore, then that becomes a vector quantity, because that is scalar with that is scalar quantity which has a direction. Now moving ahead, a scalar, I will have to give you examples for scalars and vectors. So one I have given, that is distance, the distance and displacement. Distance is an example for scalar. Why? You will be given with a tape and I will ask you to measure the distance from one point to other point and you will measure it. So that now say for example I have to measure the distance from here to here. This point, say for example this is my house in Mysore and this is the college situated at the border of Mysore and Mandya. Say this is Mandya. Now I will have to reach from Mysore to Mandya. To do so, I will not have the trajectory of a flight so that I can straight away come from the college, from my house to college, but I will have to go with a lot of other roads, take other roads and reach the college. So this is nothing but the distance travelled. Now the shortest distance between these 2 points is termed as displacement. Now, why is this a shortest distance? Because it has a proper direction. So, this is nothing but displacement. The shortest distance travelled between any 2 points is called displacement. What is the unit of distance and displacement? Distance, when you measure, here starting from here, it is, say for example, 15 kilometers. Whereas, the shortest distance between these 2 points is fetching me, say, 10 kilometers. Both are measured with the same unit. So, unit for both distance and displacement is meter. Both for distance and displacement you have meter. Now, I will continue further digging it. Now, I will start from here and reach this 15 kilometers, say in 1 hour. Say I am cycling, that is why I am taking 1 hour. Now, from Mysore to Mandya, the shortest distance to my college, 10 kilometers, I have travelled in half an hour. Let us assume like that. Now, what is this? Why is this hour is always comes combined with the time? Because when we are travelling in a bus or train to Bangalore, what do we say? We will reach in 2 hours, we will reach in 3 hours. What does that mean? The 150 kilometer distance between Mysore and Bangalore is covered in 3 hours. So, this is the distance by time, the distance travelled by time taken is nothing but called speed. Speed is nothing but distance travelled per time taken or time taken to cover a certain distance. This is nothing but the unit will be meter per second. Similarly, I have told you that this is the displacement, that is the shortest distance between the 2 points. So, displacement by time is called velocity. I have told you that displacement also has the unit meter. So, unit of velocity is also meter per second. So, what have we learned till now is first the definition of mechanics. In that mechanics we had rest and motion, and then we went to forces, studied Newton's first law of motion, and then there came the quantity. So, the quantities that require only magnitude to represent them became scalars, and those which require both magnitude and direction became vectors. I will write them also, scalar and vector. As examples to them, I have taken distance and displacement, and then I took speed and velocity. Now, can anybody tell to themselves what quantity is speed? Whether speed is a scalar or vector? Speed means distance by time. So, the speed has only magnitude but no direction. That means I am running at a speed of 10 km per hour will only signify a scalar because it is not having any direction. But I run 10 kilometers per hour starting from Mysore towards Srirangapatna has a clear direction as well. So, that means velocity becomes a vector quantity. Speed, velocity, and I will have to next teach you what is acceleration. Assume that you are driving your vehicle from your house to your friend's house. You are riding at 50 km per hour. Your moped is being run at 50 km per hour. You see an empty road, there is no vehicles from the opposite direction, and you wish to increase the speed. So, you will obviously you will use the accelerator of your vehicle. What is it actually doing? What is it actually doing? It is increasing the velocity of your vehicle. That why I say velocity and not speed is you are moving in a particular direction. In the same direction, your speed has to increase. That means velocity has to increase. That cannot be termed as speed because it has a particular direction. Your velocity has to increase in that direction. So, you will accelerate. That means what is acceleration? The same distance is being covered in a short time. That means the rate of change of velocity is called acceleration. The rate of change of velocity. Okay. Whenever you have rate in the definition, you will always have time in the denominator. That means acceleration is rate of change of velocity. That means velocity is in the numerator, time is in the denominator. So, what is the unit of velocity? Unit of velocity is meter per second, unit of time is second. So, it becomes meter per second square. This is the unit of acceleration. Now, I have given you an example of an empty road wherein you would wish to increase the speed, but when there is an opposite vehicle or a dog that comes without your notice, immediately what will you do? You will have to apply the brakes and automatically your velocity decreases, but that velocity is still in the same direction. But whenever you will move in the opposite direction, then it becomes deceleration. Deceleration or negative acceleration, that also has the same unit, but it will come with a negative sign to signify it. So, speed, velocity and acceleration, and next we will move on to momentum. What is momentum? I hope many of you watch a cricket game. During the commentary, you might have heard that some ex-batsman has entered the crease and he has changed the momentum of the game. What does he actually do? He would actually have, say for example, the score of Indian cricket team is at 3 runs per over. Now, immediately a hard-hitting batsman comes on a given good day, he starts hitting the ball and your run rate has increased to 4.5 in 3 to 5 overs. So, what has happened is, by virtue of his capacity of playing good cricketing shots, he has increased the run rate. So, he has brought in some force. So, momentum is nothing but mass, that means the quality of the player, let us assume, into what has he done? He has increased the scoring rate. So, I will take it as velocity. So, momentum is nothing but mass into velocity. So, what should be the unit of this mass into velocity? Mass has a unit of kg, velocity has a unit of meter per second. So, momentum is nothing but mass into velocity in kg meter per second. Why is this important in learning? Is with the increase in mass, the momentum will change, or if the mass is constant, with the increase in velocity, the momentum will change. Or basically the definition goes like this: it is the capacity of a body to impart motion to other body or impart force onto other body. When in the example that I have given, the batsman has come and started hitting, that has not just improved his batting rate, but also has increased the team's batting tally. That means it had the capacity to impart motion to the other body. So, that is called momentum. So, these are all the basic things that are all required to learn the modules that come across in the future classes. Going ahead in the basics, I will have next, okay, when I say momentum, on momentum you have the Newton's second law based. I will tell you what is Newton's second law and what is its importance. I have talked about momentum here, that is mass into velocity. Newton's second law say that the rate of change of momentum, the rate of change of momentum of a body is directly proportional to the applied force and the direction of it. That's why I have first taught you what is force. Now when you know momentum, the rate of change of momentum is directly proportional to the applied force and its direction of application. So where have you seen the change of momentum? Say for example, I keep giving you the examples of cricket, don't mind if you do not like cricket. Now when you throw a ball from a particular place towards the wicket, towards the stumps, what would actually happen? Let me say you have a ball at hand which has the mass equal to m. Now you throw the ball. So it will start moving with a velocity say u, and it keeps moving, and at another point before it reaches the stumps, let us assume right in the trajectory of the ball, will the mass of the ball change? The same leather ball you have in the hand, you throw, the mass of the ball doesn't change. So the mass of the ball will still be m, but let us say it has changed its velocity to v. The time taken between the change of velocity is t. To understand this, when a ball is thrown, if a person stands here and gets hit by that ball, he will have a lot of pain, whereas a person standing 10-15 meters away from the throw will definitely feel a different force. So now let the initial velocity be u and the final velocity be v, and the change must have taken, or change may have taken with in a time interval t. So what is the momentum at this point? We know that momentum is mass into velocity. Here the momentum is mass into velocity. What is the velocity here? Velocity here is u. What is the mass of the body here? Still m, but velocity has changed to v. What does Newton's second law state? The rate of change of momentum. Very careful, it is rate of change of momentum. I have only written momentum here, you will have to take the change in momentum. What is the change in momentum? Say you score 56 in a subject, and in the next you will score 66. What is the difference, or what is the change? It is 66 minus 56. Similarly here, what is the change? So I will write here, change in momentum is equal to final velocity, that is m into v minus initial velocity m into u. But the definition says it is rate of change of momentum. Rate of change of momentum. So when I have already told you, when there is rate in the definition, you will have time in the denominator. That means mv minus mu is there. I will take m outside, m into v minus u divided by time. Time interval here is t. M into v minus u by t. But what is v minus u? What is v minus u? V minus u is change in velocity. In the denominator you have time. You must now recall what I have taught you in this class itself. This is nothing but change of velocity with respect to time. What is change of velocity with respect to time? That is just nothing but acceleration. That means this can be written as m into a, acceleration a. This is Newton's second law. But here it doesn't end, because according to the law, this rate of change of momentum must be proportional to the applied force, and it has to take place in the direction of the applied force. That means m into a must be proportional to the applied force. Now to remove the proportionality, I will have to bring in the constant of proportionality. Say f is equal to k into ma. When k is unity, you have the actual output of the Newton's second law, that is f is equal to m into a. This is a very important part in learning the fluid mechanics. Please keep this in mind. Force is equal to mass into acceleration. Now you must have already learnt about acceleration due to gravity. What is acceleration due to gravity? Acceleration due to gravity is the pull of the earth due to the earth's gravity. That means that is usually termed as g. Acceleration due to gravity is termed as g. I will come to it later because I will have to deal with mass, weight and volume. When I come to weight, I will tell you what that g, the g is important will be told then. Now for the time being you can understand and remember F is equal to m into a. So now this is Newton's, after momentum I will write Newton's second law. Next, in the basics you will have to know about work, energy and power. We'll first take up what is work. Now I am holding a piece of chalk in my hand. This is work, and if I have to place this from here to here, this is also work. If I have to place this from here to here, then this is also work. Basically what is being done here? Basically I will have to be able to lift this piece of chalk and move. So some force is required, and with force what is happening? Now force is being applied to do what? To displace this from one place to other place. Now I have gone backwards, now I am coming forward. So there is a displacement, clear displacement. This is happening because of the force being applied. So work is nothing but force into displacement. Force into displacement. Force has a unit called Newton that came because of the previous derivation that I have done. Newton's second law, wherein F is equal to ma came, that was found by Newton. So force has a unit of Newton, that I did not write. If you want I will show. F is equal to m into a was the output of the previous derivation. M is in kilogram, acceleration is in meter per second square. Since Newton found this, put together this is called Newton. So force has a unit of Newton, displacement is in meters. So work has a unit of Newton meter. And next in the line I have energy. What is energy? Energy is nothing but the capacity to do the work. That means any work can be converted into, in fact I will have to go the other way, any energy is nothing but the work. The capacity of doing it is called energy. So it has the same unit, Newton meter. But in energy you have two famous types. Everybody will answer this. One is kinetic energy, the other one is potential energy. What do you mean by potential energy? Potential energy is the energy gained by virtue of the position of the body, whereas kinetic energy is the energy gained by virtue of the motion of the body. So potential energy is dependent on its position, where h is the height, that means the position of the body. Mg is nothing but the weight of the body, whereas kinetic energy is half mv square, where v is the velocity. It depends on mass and velocity of the body. And finally you have power. Rate of doing work is called power. Whenever there is rate, I have told you that in the denominator you will have to have time. So what do we have to have in the numerator? It is rate of doing work. That means work. Work by time, that is nothing but Newton meter per second. So this is nothing but the power, rate of doing work. So these are the few concepts that you must know before entering into the other part of the title of the course, that is fluid mechanics. I have just elaborated about or taught you about the mechanics part of it, and now we will move on to the other part is fluids. Before I get into fluids, I think I must also let you know what is mass, weight and volume, because I have already used mass as well as weight in this class itself. What is mass? Okay, I'll have to pose a very simple question here in Kannada, because nim tooka estu. This is a common question that you will come across. What does that tooka mean? That means, is it a synonym to weight or mass? That is the question that must rise. Whenever somebody asks us what is your weight, the quick answer would be say 80 kgs. Is that correct? That you will learn now. That is basically incorrect. What we are answering is mass and not weight, because mass is the measure of amount of matter contained in a body. Say this is a body. I am made by what? Blood, other muscles, bones, all those things. It is the measure of amount of matter contained in this body, and that doesn't change. If I jump, my mass doesn't change, because the amount of matter contained in the body doesn't change. So what we answer whenever we are asked about our weight is actually the mass. Unknowingly we are doing that. We will have to change from now, but people will not accept that answer. I will tell you why. Mass is the measure of matter contained in a body, and its unit is kg. And now if I throw this duster up like this, and it has to fall down. Why is it falling down? It is falling down because of the acceleration due to gravity. But does the mass of this duster change just because it went up and came down? No. So mass is not changing. But what is changing? Say for example, this duster, when I lift this up and put it down like this, the force that I am feeling on my hand is less. But when I put this up from a greater height, the force that I feel here will be different. And now this mass, the same mass when it is multiplied by the acceleration due to gravity, that means depending mass is m, acceleration due to gravity is g. You must now relate this with the Newton's second law, which said F is equal to m into a. Here instead of F we will write weight. That means to say weight is a force. Weight is a force. How? Because this is mass multiplied by acceleration. Here acceleration due to gravity, that is the only change. So this must also be in terms of Newton. So what is the difference between mass and weight? Whenever somebody asks your weight, you must put it in terms of Newton. People will laugh at you. Don't do it. Now, but you must, as a civil engineer, you must be knowing this fact. Weight has a unit of Newton, and mass being multiplied by acceleration due to gravity only gives weight. And then finally you have volume. You will all have seen the sumps in your houses or water tanks, or to give you a bigger picture, the lakes. Since you reside at Mysore and near Mysore, you have many tanks. Kukralli Lake you have Karanji Lake. All those things has a capacity to store something. That means now the room I am standing in, if you observe here, this is the one dimension, that is the width of the class, let us assume. Then the height of the class is also visible, and then you have the length of the class. These three dimensions put together will give you, I will write 3 dimensions put together will give you volume, or basically area multiplied by height will also give you the volume. So this is m into m into m, that is equal to m cube. Since the subject that we are going to study in future is fluid mechanics, I will give you an example of sump or tank. How much is the volume of the sump? This is an activity that I am giving to you in this class. Go to your sump, measure the length, width and height of the tank or sump, and multiply them. You will get the volume of your tank, and that shall be in meter cube. Now I will move on to the last part of this introductory class, wherein I will be dealing with fluids. as I have told you, I have completed a few basic things about mechanics. It is also important for us to learn about fluid. Before I get into fluid, I will have to tell you about the states of matter. While I spoke about bodies, I told you that anything that is available on earth can be taken as body for the purpose of study. Then what are the types of materials that we have on earth? All those things are bifurcated into only two parts, solids and fluids. But as a beginner in science, you would have been taught there are three states of matter, that is solid, liquid and gas. Basically, anything that has the capacity to flow is called a fluid. Both liquid and gas can flow, so we have put them together and we will call it as fluid. So there are only two states of matter, one is solid, the other one is fluid. Now I have already taught you what is mechanics. What is mechanics? I repeat, it is the branch of science that deals with the action of forces on bodies at rest or in motion. Remove that body from there, put solid, it becomes solid mechanics. You remove solid and put liquid there, it becomes fluid mechanics. So what is the definition of fluid mechanics? Fluid mechanics is a branch of science that deals with the action of forces on fluids at rest or in motion. Now what is that? If we put solid, it becomes solid mechanics, and you study it as strength of materials in this third semester itself. What we will be dealing with is fluid mechanics. What is that? I repeat, the study of action of forces on fluids at rest or in motion. You will also have to learn about three engineering properties through which you can know better about fluids, and that will be taught to you in the coming classes. Hope this session was useful. For any doubts, you can contact back to me. Thank you.